Hello everyone, this is Jason Sikes, aka the Tech Rancher, here to show my solution for homework lesson number 10 given by Paul McWhorter. Paul does several series on the Raspberry Pi Pico W. This is lesson number 10 that I'm doing my solution for. Let's go ahead and take a look at what I've done here. Paul had asked us to make a circuit that would take the potentiometer data or value to be able to control an LED as a dimmer. So here you can see my schematics that I did for my circuit. I'm using the ground pin number 3 going to the ground rail. I have a node here tying to the potentiometer. It's the ground side, and the positive side will come out to 3.3 volts from pin number 36 going to it. Then using GPIO pin 16, which is actually counting pin number 21, going to the 330 ohm resistor going to the anode leg of a red LED, which is also ties to ground. Alright, then we got reading out value from the potentiometer is the GPIO 28. Now let's go over here and look at the code that we got here set up for this. I'm importing library machine and the objects of pin, ADC, and PWM. Importing time and object sleep. And I'm calling my variables for my LED using pin GPIO 16 and pin GPIO 28 for running the potentiometer. I declared for being able to do my if statement. I'm declaring some variables here to be able to so I can change them if I ever wanted to, and not have to go back through my code to look for it. Then created my object here, the LED, which is a pulse width modulator, PWM, and it's on pin out LED. Frequency of 1000 millihertz, and a duty cycle of 0 right now, which will change that. Well, you actually use the value from the potentiometer inputting into that. Then we're calling in the value into the Pico through the ADC, which is analog to digital conversion, and we're using that into pin number 28. Got a program loop try and an accept. While true, here we go. We're going to start our code. We're getting the value from the potentiometer. I printed it out to make sure I was getting the value out of it. And then I ran it through an if statement. This is once again where I use this here. So if it's at a maximum amount of over 65,535, well, I want to change that to actually 65,500. We're going to go ahead and call it at 65,535. So we're going to make it at 3.3 volts, sending to the LED. Then I'm saying the minimum of 700, so therefore we can minimize any bouncing that it has. I've been having issues with the bouncing, so I brought it up to 700. And then we'll say if it is less than 700, go ahead and turn it off. And then we sent the values from the potentiometer to the pulse width modulator to control the LED. Alright, now let's take a look at that in here and see what this looks like. Let me get that set up so you can see it. Alright, camera's here. Let me zoom in a little bit if I can. Let's make it a little bit nicer for us to see and in focus. Alright, here we go. Well, it turned anyway. I'm gonna start it. Okay, as you can see, we're getting data from the potentiometer, but right now it's not enough to turn on the LED. Well, you see that? I'm still getting a little bit of bounce right when I very first touched it. Anyway. There we go. It's just now coming on, and we just keep on turning it. The board wants to move too. As we keep on turning it, you can see the LED is getting brighter and brighter and brighter. And there you go. It maxed out. Now come back down. This is all smooth. And coming down lower and lower. And there it's done. It's off. I did not do any math because I realized that the potentiometer uses the same data output as the pulse width modulator uses for an input. So I like the acronym KISS, Keep It Simple Smarty. So I'd minimize any kind of math I want to do, but you can do math. You can be able to use it. One of them I saw it the best would be is to do a percentage math. Oh, see, there you go. You can still see it's bouncing. But there you go. I have it. If you have any questions, please leave a comment down below. I'll do my best to answer as quick as I can or as soon as I can. Thank you.